The station enters orbital night gradually enough that nobody inside ever reacts to the exact moment it begins. One section of the Pacific loses sunlight first. Then the cloud tops stop reflecting. Then coastlines fade into dim orange fractures before those disappear too. The transition takes several minutes if you sit still long enough to watch it happen through the window above the equipment rack. At first, the planet still feels completely recognizable. The shape remains familiar even after most of the visible surface is gone. White weather systems continue turning across darkness that no longer reveals the water beneath them. Thin lightning storms pulse inside continents already hidden from direct view. A curved blue edge remains suspended along the atmosphere, faint enough now that it reflects across the metal wall panels more than the glass itself. One astronaut floats slowly past the hatch carrying a folded checklist attached to his wrist with elastic bands. He catches the side rail with 2 fingers, stops his momentum, glances once toward the window, then disappears into the sleeping compartment without saying anything. It happens every orbit. After enough weeks up here, people stop announcing sunrise and nightfall. The station crosses both too often for ceremony to survive. Morning arrives roughly every 90 minutes. Darkness returns just as quickly. Human routines adapt badly at first, then almost perfectly. Coffee packets drift inside mesh compartments beside emergency batteries. Loose pencils collect near ventilation filters. Somebody always leaves one pair of headphones floating near the communications panel because gravity no longer reminds anyone where objects belong after they stop paying attention. The station hum remains consistent through all of it. Fans cycle air through narrow ducts behind the walls. Cooling pumps vibrate softly beneath the floor panels. Somewhere farther down the module, metal contracts with a sound almost identical to distant footsteps. Earth continues rotating outside without requiring observation. For several minutes, the only visible part of the planet is the atmosphere itself. Not the surface, just the edge. A thin band of scattered light tracing the curve of a world that has mostly disappeared into shadow. The strange part is how little information the brain actually needs before recognition locks into place. Even now, with nearly everything hidden, nobody looking through the window mistakes it for anything else. The continents are gone. The oceans are invisible. Entire weather systems vanish into the dark interior of the sphere. And still the mind immediately understands what it is seeing. A planet does not need to remain fully visible to remain emotionally complete. The station commander mentions this once during a recorded systems check, almost by accident. The transmission is old now, replayed later inside a training archive on Earth while rain moves across the windows of a classroom in Houston. He says that after several months in orbit, people stop identifying Earth by landmass first. They identify it by movement, by curvature, by the atmosphere scattering sunlight before the surface itself appears. Eventually, the planet becomes recognizable through behaviors instead of details. The recording continues for another 3 minutes after that, mostly discussing battery cycling procedures and water recovery filters. Nobody in the room responds to the observation. A student scratches notes into a paper workbook. Someone coughs near the back wall. Outside the building, cars continue passing through wet intersections under ordinary weather that almost nobody notices anymore because they live inside it continuously. The station emerges briefly over the Indian Ocean. Moonlight reflects across cloud formations far below, weak but sufficient to reveal structure again. Cyclone bands rotate slowly near the lower edge of the window. Thin river systems appear for only a moment before drifting back into darkness. Then the reflection angle changes. Everything disappears again. Inside the module, one astronaut secures himself beside the observation port before sleep, not to observe anything specific, mostly because the window is one of the few places where the body can briefly forget the station interior. He hooks one foot beneath a restraint bar and turns off the cabin light. Now the glass only reflects instrument LEDs and the faint blue atmospheric line outside. The continents remain invisible, but the planet still feels present. That feeling becomes oddly procedural after enough repetition. People adapt to partial visibility faster than expected. Pilots learn this during instrument failures. Sailors learn it in fog. Divers learn it underwater. Memory fills gaps automatically once recognition begins. The station window reveals less than a complete Earth for most of every orbit, sometimes far less. And yet, nobody aboard experiences the sensation of looking at fragments. The mind keeps reconstructing the whole object continuously from very small pieces of evidence. A curve, a glow, cloud motion, one familiar color against blackness. The astronaut near the window closes his eyes for a while, but does not leave. Behind him, equipment lights continue blinking across the darkened module. Green indicators, occasional amber warnings, faint reflections drifting slowly across metal surfaces as the station adjusts orientation for the next daylight pass. Outside, Africa is already moving into darkness again long before the station reaches Europe. Entire populations disappear from visibility without disappearing from awareness. The planet remains emotionally intact even while most of it cannot currently be seen. And after enough hours watching orbital night move across the surface, it becomes harder to tell whether recognition depends more on visibility or memory itself. Cloud cover moves across the Gulf Coast in long, uneven bands, thin enough in some places for entire cities to appear underneath, then dense again a few seconds later until everything returns to black water. From orbit, the transition feels less like geography and more like interrupted circuitry. Houston appears first. Not the shape of the city itself, just a concentrated orange pattern spreading outward from the coastline in connected strands. Highways remain visible longer than neighborhoods. Industrial ports burn brighter than residential districts. Offshore drilling platforms stand isolated in the water as tiny fixed lights separated from land completely. Then clouds drift over the region and the entire network disappears at once. Only the atmosphere remains visible again. Inside the station, somebody adjusts a sleeping bag restraint near the wall panel beside the window. Velcro separates with a rough tearing sound that briefly cuts through the constant ventilation hum. A checklist tablet rotates slowly loose beside one of the handrails until an astronaut catches it absent-mindedly and presses it flat against the storage compartment. Nobody says much during orbital night. People still move through routines. Battery readings, water recovery status, scheduled communications. But voices become quieter after the lights outside disappear. Not emotionally, more like the station itself encourages lower volume once Earth stops reflecting sunlight through the windows. The next coastline emerges beneath thinner cloud cover. Northern Europe this time. Cities appear in clusters, separated by long regions of almost complete darkness. Roads connect them in faint, branching lines that only become visible after your eyes adapt fully to the interior dimness of the module. The oceans absorb nearly everything. That becomes difficult to ignore after a while. From the ground, coastlines feel permanent, borders feel mapped, populations feel continuous. But from up here, most of the planet spends the night visually erased except for the places where humans generate enough electricity to announce their own presence against the surface. The rest becomes almost unreadable. An astronaut once described orbital night as watching civilization leak through cloud cover. The phrase survives in an archived interview recorded years earlier inside a cramped radio room while static moves quietly beneath the transmission. The interviewer laughs a little after hearing it. Not because the observation is funny, but because it sounds overly dramatic at first. Then the camera turns toward the window, and the description suddenly feels exact. Cities do not glow evenly. Some pulse through atmospheric haze. Others flicker weakly near mountain ranges or coastlines before vanishing beneath weather systems moving far above them. Entire countries disappear under storms while isolated fishing fleets remain visible offshore as tiny drifting constellations. Electrical infrastructure becomes easier to recognize than the land itself. The station crosses over Central Asia. Large sections remain almost completely dark, except for scattered concentrations near rail corridors and industrial regions. One isolated cluster appears briefly beside what cannot even be visually confirmed as a river until moonlight catches the water several seconds later. Recognition arrives in fragments now. Not from continental outlines, from artificial illumination, from repeating human patterns. A curved shoreline lined with ports. A concentrated inland grid. A highway corridor extending through otherwise invisible terrain. The station computer emits a soft tone from one of the navigation panels. Position correction completed. Nobody reacts. One crew member pushes gently away from the communications console and drifts toward the galley compartment holding a sealed drink pouch between both hands. Earth continues below in almost total silence. The strange adjustment happens slowly. At first, the illuminated regions feel small against the planet. Later, the dark regions start feeling larger. Not empty, just visually unreachable. Weather moves across them continuously without revealing much underneath. Oceans absorb moonlight unless the angle is exact. Mountain ranges disappear completely after sunset. Entire deserts vanish so thoroughly that only surrounding population centers reveal where they must still exist. A continent can remain physically present while becoming visually inaccessible for most of the night. The station passes over the Mediterranean. Cloud systems thin briefly enough for coastlines to sharpen again. Italy appears immediately recognizable, not because the land itself is visible, but because urban light follows the familiar curve of the peninsula almost perfectly. Recognition through infrastructure. That realization arrives quietly, then lingers longer than expected. Back on Earth, automatic systems begin turning off unnecessary lighting inside office buildings where nobody remains awake anymore. Parking garages reduce power consumption floor by floor. Traffic signals continue cycling through empty intersections at 3 in the morning. Cell towers blink red across rural hillsides where almost everything else has already disappeared into darkness. From orbit, those systems become part of the planet's visible surface. Not metaphorically, literally. Without them, much of human presence would vanish from immediate observation after sunset. The clouds over the Atlantic thicken again. Most of the window turns black except for occasional reflected lightning inside distant storm systems. Small islands appear briefly as isolated amber points surrounded by enormous sections of invisible water. Then even those disappear. Inside the station, the observation window now reflects more of the interior than the Earth below. Storage straps, dim indicator lights, a floating pen turning slowly in the recycled air current near the ceiling vent. Outside, another coastline begins forming beneath the clouds. Not visible yet. Only a faint concentration of orange light spreading gradually through the atmosphere before the land itself can be seen. The first sign of orbital sunrise is not the surface. It is the atmosphere. A thin blue curve begins forming along the edge of the Earth several minutes before any continent becomes visible beneath it. At first, the line looks almost artificial, too narrow to belong to something planetary. Then the station changes orientation slightly and the glow spreads farther across the lower edge of the window. Still no land. Still no oceans. Just atmosphere catching sunlight before the planet underneath receives any at all. Inside the observation module, one of the mounted cameras automatically reduces exposure compensation as brightness levels begin rising across the frame. The adjustment happens slowly enough that nobody notices it directly unless they are watching the monitor itself instead of the window. Numbers shift. The image darkens slightly, then stabilizes again. The blue line remains. An astronaut wipes condensation from a small section of the glass using the sleeve of a gray exercise shirt. The moisture smears briefly before disappearing completely. Outside, the atmospheric edge sharpens another degree brighter. The strange part is how little there actually is. From the ground, the sky feels enormous. Endless weather above cities. Layer after layer of cloud structure extending across entire continents. Commercial aircraft disappearing upward until they become invisible. Storm systems reaching high enough to distort sunlight over hundreds of kilometers. But from orbit, the visible atmosphere compresses into something unexpectedly thin. Not metaphorically thin. Visually thin. A narrow, illuminated layer wrapped around the curvature of the planet like condensation along the rim of cold metal. The station continues moving into sunlight. Now faint surface detail begins appearing underneath the glow. Northern Africa emerges first through scattered haze. The Mediterranean reflects silver for a few seconds before clouds diffuse the reflection again. Coastlines become readable only after the atmosphere has already announced their arrival. The order matters more than it initially seems to. People expect planets to define their atmospheres. From orbit, the atmosphere often defines the planet instead. One flight engineer describes this during a maintenance recording while recalibrating a camera mount beside the observation cupola. His voice remains mostly procedural. Focus settings, exposure lag, window reflection interference. Then somewhere in the middle of discussing lens flare contamination, he pauses for several seconds. He says the atmosphere is what makes Earth readable. Then he continues adjusting the mount without explaining the thought further. The recording ends 20 minutes later with battery statistics and storage capacity reports. Outside the station, sunrise continues uninterrupted regardless. The blue edge thickens briefly as viewing angle changes, then narrows again. That variability becomes difficult not to notice after repeated observation. Visibility depends on geometry constantly. Light angle, atmospheric density, cloud position, observer location. Sometimes entire continents appear immediately beneath orbital sunrise. Other times the atmosphere brightens beautifully, while the surface below remains almost featureless for several additional minutes. The Earth does not always reveal itself all at once. Inside the module, floating dust particles become visible in the incoming light. Small fragments drift through the cabin air current near the ventilation intake, glowing briefly before vanishing against darker wall panels. One crew member secures a loose cable beside the communications rack using strips of worn gray tape already folded back on themselves from previous adjustments. The station smells faintly metallic during orbital morning. Recycled air, warm electronics, coffee residue trapped inside filtration systems after years of continuous operation. Outside, the atmosphere continues doing something deceptively simple. It scatters sunlight sideways across the edge of the planet before most of the surface itself becomes visible. That single process changes almost everything humans emotionally recognize as Earth. Without atmospheric scattering, orbital sunrise would behave differently, harder, faster, more abrupt. Oceans would darken toward black more aggressively. Daylight boundaries would sharpen. The transition between visible and invisible would feel mechanical instead of gradual. A planet can become emotionally familiar through softness alone. The realization arrives awkwardly. Not dramatic enough to feel important immediately, just persistent. The station crosses farther into daylight. Cloud systems over Eastern Europe begin reflecting direct sunlight now. Rivers appear intermittently between haze layers. Snow cover near mountain ranges flashes bright enough to force another automatic exposure correction across the observation monitors. Again, the cameras compensate. Again, the atmosphere remains visible longer than everything beneath it. An archived training video from decades earlier plays inside a classroom somewhere in Kazakhstan. A former cosmonaut stands beside a projection screen explaining horizon photography to new recruits preparing for long-duration missions. He tells them that first-time observers usually photograph the continents. Experienced observers photograph the atmosphere. Not because it looks more beautiful, because eventually they understand what they are actually seeing. The clip continues another few minutes before cutting abruptly into unrelated navigation material. No conclusion follows the statement. None is needed. Back inside the station, the observation window has become bright enough that reflections from the interior nearly disappear. Storage compartments fade from the glass. Instrument lights become difficult to see unless viewed directly. The blue atmospheric line remains suspended along the edge of the world beneath everything else. Still narrow. Still fragile looking. The strange adjustment happens slowly. At first, the atmosphere feels decorative. Then it starts feeling structural. Not visually large enough to matter, yet responsible for nearly every soft transition the planet produces from orbit. Color gradients, cloud illumination, diffused sunrise, haze above coastlines. The reason Earth remains readable during conditions where harder surfaces would already vanish into blackness? The station drifts farther into full daylight. Now the continents appear obvious again. Cloud systems rotate visibly across oceans. Desert regions sharpen beneath clear air. Mountain shadows stretch long across the surface near the edge of morning. But the eye keeps returning to the same thing. That thin blue line. Barely visible unless sunlight strikes it correctly. And somehow carrying most of what makes the planet look alive at all. The horizon begins fading before the planet does. At first, it looks like a camera problem. The observation window faces mostly into darkness again as the station moves through partial eclipse conditions, and one of the external cameras keeps searching for contrast that no longer exists cleanly enough to lock focus. Exposure values shift every few seconds. The image brightens, washes out slightly, then darkens again until surface detail almost disappears completely. But the Earth is still there. That becomes strangely difficult to prove visually for several moments at a time. Inside the module, a crew member braces one hand against the window frame while adjusting manual exposure controls through a floating tablet interface tethered near the cupola wall. His thumb moves slowly across brightness settings while the live image responds with delayed corrections. Too bright, and the atmosphere disappears. Too dark, and the continents vanish first. Somewhere in between, the planet becomes recognizable again. The station continues drifting along the edge of shadow. Usually, the curvature of the Earth remains obvious, even when weather systems and coastlines fade from visibility. The horizon separates planet from surrounding blackness clearly enough that the eye reconstructs the rest automatically. Tonight, the separation weakens. The atmosphere no longer scatters enough light to maintain a clean boundary. The blue edge from orbital sunrise has thinned into something gray and uneven, visible in one section of the window while disappearing entirely in another. For several seconds, the curve dissolves almost completely into surrounding space. Not because the Earth has vanished, because the edge has... The effect feels wrong immediately. Not dramatic, not frightening, just visually unstable in a way the brain does not process comfortably at first. Humans recognize objects through boundaries constantly. Tables against floors. Buildings against sky. Faces against surrounding rooms. Even clouds depend on contrast to become readable shapes instead of diffuse brightness. The station cameras behave similarly. Without clear edge separation, automated systems begin overcorrecting exposure because the image no longer contains enough distinction between foreground and background. The Earth starts behaving less like an object and more like a gradual transition. Inside the station, somebody opens a storage compartment near the galley, and the sudden rectangle of interior light reflects sharply across the observation glass. For a moment, the reflection becomes brighter than the planet itself. Packets drift outward slightly before being pushed back inside. Velcro seals again. The reflection fades. Outside, the horizon remains difficult to track. One astronaut describes this phenomenon quietly during a technical debrief recorded years earlier after a low-visibility orbital pass above the Pacific. He says losing the horizon feels different than losing the surface. When continents disappear, the mind assumes they still continue underneath darkness. When the horizon disappears, orientation itself starts weakening. The recording contains long pauses between sentences. Not emotional pauses, more like someone trying to describe a visual condition accurately without exaggerating it into something more philosophical than it actually felt. He eventually compares it to flying through fog over open water at night. No reference points. No stable separation. Just gradual tonal differences where edges are supposed to exist. Outside the station, lightning storms pulse inside cloud systems over South America. The flashes briefly restore planetary shape from within rather than from the edge itself. For half a second, the Earth becomes readable again through internal illumination. Then the flashes stop. The boundary disappears once more. The strange adjustment begins procedurally. At first, the crew keeps trying to restore visibility through camera settings, contrast modifications, manual aperture compensation, reflection reduction. They clean the glass again, even though the problem is not the window. Eventually, the observation changes direction. The issue is not visibility alone. It is separation. A planet remains recognizable partly because the eye expects it to end somewhere. The atmosphere normally performs that task continuously. Even a thin, illuminated edge tells the brain where Earth stops and everything else begins. Without that line, oceans blend gradually into shadow. Cloud tops lose depth. Continents stop feeling anchored to curvature and start looking suspended inside darkness instead. The station crosses farther into eclipse. Now the atmosphere survives only as faint sections of uneven gray light near the lower edge of the frame. The rest dissolves completely. One crew member disables automatic exposure correction entirely. The image stabilizes immediately. Darker now. Less detailed, but calmer. The Earth stops fluctuating. Sometimes reduced information feels more trustworthy than unstable correction. Inside the module, ventilation fans continue their constant mechanical hum behind the walls. Somebody drinks water from a transparent pouch while watching the observation monitor without speaking. Small air bubbles drift upward through the pouch in slow, irregular motions each time the station changes orientation slightly. Outside, the Pacific reflects almost nothing. The horizon disappears again for several full seconds. Yet the planet still remains perceptible somehow through motion alone, through the way cloud systems drift together, through faint atmospheric gradients too weak to define edges clearly but still strong enough to imply structure underneath. Recognition begins depending on indirect evidence now, not direct visibility. The realization arrives slowly enough that nobody aboard reacts to it emotionally. Procedural adaptation takes over first. Lower exposure, longer observation. Fewer assumptions about what should remain visible continuously. The Earth becomes readable again eventually, but differently than before. Less through outlines, more through relationships between faint moving layers of light. The station exits the weakest part of eclipse gradually. A thin atmospheric boundary reforms along one side of the world beneath the window. Weak at first, barely visible, then slightly brighter after another few minutes as sunlight geometry changes again. The horizon returns before the continents do, and the planet immediately feels more solid simply because something is separating it from the surrounding blackness once more. The monitor overlay drifts slowly across the screen, even though the telescope mount is technically locked on target. A thin tracking marker slides 2 millimeters left, corrects itself, pauses, then moves again. Small alignment numbers update continuously along the lower edge of the display while stars remain fixed in the background. Earth sits near the center of the frame. At least the software believes it does. Inside the orbital observatory module, the room stays mostly dark except for instrument panels and the pale wash of monitor light across exposed metal brackets near the workstation. One technician rotates gently in place while checking calibration data from a floating tablet secured to the console with braided cable ties. His sock catches briefly against the underside of a restraint rail before he pushes himself still again. Nobody speaks for several minutes. The tracking system keeps correcting. Outside the window beyond the monitors, dense star fields remain perfectly stable compared to the planet drifting through them. That reversal takes time to emotionally process. From Earth, the stars appear fixed because the ground beneath observers feels stable. From orbit, stability changes owners. The stars barely move. The planet does. One of the observatory cameras attempts object isolation automatically. The faint square overlay forms around the Earth, then loses edge confidence almost immediately as cloud cover rotates across the visible hemisphere. Tracking confidence drops. The square disappears. A new overlay forms slightly lower, then readjusts again. The problem is not that the Earth cannot be seen. The problem is that the software keeps needing context to understand what it is seeing. The observatory exists partly for this reason. Long-duration imaging systems depend on reference points continuously. Without stable background alignment, even extremely advanced tracking systems begin drifting slowly off target. Stars provide the reference. The Earth provides the movement. That relationship becomes visually uncomfortable after enough observation because the brain expects the opposite arrangement instinctively. Inside the module, somebody unwraps a compressed food packet, and tiny crumbs immediately drift into the airflow before being caught against a mesh intake filter beside the workstation. One technician wipes fingerprints from the monitor glass using the edge of a soft maintenance cloth already stained darker from years of repeated use. The alignment marker slips again. Corrects again. The Earth remains visible the entire time. But visibility alone no longer guarantees stability. An archived observatory training session from decades earlier plays quietly through headphones worn by a graduate technician during overnight calibration review somewhere in Chile. Rain taps lightly against the outer dome while an instructor explains background subtraction procedures beside an aging projection screen. He tells the trainees that objects become easier to recognize when surrounded by stable comparisons. Brightness means more beside darkness. Motion means more beside stillness. Edges become clearer beside interruption. Then he spends 40 minutes discussing software thresholds and optical noise reduction. The philosophical implication never gets mentioned directly. Outside the orbital observatory, the Earth drifts beside thousands of visible stars. For a while, the effect actually weakens recognition instead of strengthening it. Without atmosphere defining the edge strongly enough, parts of the planet blend gradually into surrounding fields of light. City illumination competes visually against dense stellar regions behind it. Thin cloud layers reflect weak sunlight unevenly across the hemisphere, while stars remain sharp and mathematically stable by comparison. The eye keeps searching for hierarchy. Foreground. Background. Object. Environment. Sometimes the distinction feels briefly negotiable. One telescope operator manually reduces star visibility through contrast filtering. Half the background field disappears instantly from the display. The Earth becomes easier to isolate immediately afterward. Cleaner. More obvious. Less visually confused. The result should feel artificial. Instead, it feels strangely relieving. Recognition improves once competing reference points are removed. The realization settles awkwardly into the room. Not profound enough to interrupt work. Not small enough to ignore entirely either. The station rotates slightly during scheduled orientation adjustment. Loose alignment markers shift across multiple monitors at once before stabilizing again. One technician places a strip of yellow tape beside a drifting calibration indicator to track whether the movement comes from software or physical motion. 10 minutes later, the marker returns almost exactly to the same position. The tape remains. Tiny procedural anchors begin accumulating everywhere during long-duration observation work. Pencil marks near monitor corners. Handwritten timing notes attached beside exposure controls. Small pieces of tape beside recurring alignment drift. Humans build reference points constantly once stable orientation becomes difficult to maintain automatically. Outside, the Earth crosses near the edge of the telescope field. For several moments, only part of the atmosphere remains visible, while the rest blends into surrounding darkness almost perfectly. Without the star field behind it, the hemisphere would probably remain easier to recognize. But surrounded by thousands of stable points, the planet starts feeling visually dependent on contrast relationships it does not fully control. One technician notices this late. Not during observation itself. Later, while reviewing recorded footage frame by frame after the orbital pass has already ended, he pauses the playback repeatedly. With stars visible, the Earth appears softer. With stars removed digitally, the curvature sharpens immediately. The object changes depending on surrounding information. The footage continues running silently across the screen long after the analysis technically finishes. Inside the observatory, cooling systems cycle louder for several seconds before settling again into steady background vibration. Somebody secures a floating wrench beneath an elastic restraint cord. A pen drifts slowly across the workstation until intercepted absent-mindedly by an open hand without anyone looking away from the monitor. The alignment markers continue moving slightly. Correcting. Recentering. Searching for stable reference. Outside, the Earth remains suspended beside the starfield, visible enough to recognize but no longer feeling visually independent from the conditions surrounding it. The first blackout appears along the coastline almost gently. One section of illuminated shoreline near the Gulf of Mexico dims slightly, flickers twice through thin cloud cover, then disappears completely from the orbital image. The surrounding cities remain visible. Offshore platforms still burn steadily in the water. Highway networks continue glowing inland. Only one region goes dark. At first, the observatory software treats it like weather interference. A tracking label shifts position. Brightness thresholds recalculate. The monitor pauses briefly while comparing the live image against older nighttime reference maps stored in the system archive. Then another section disappears. This time farther north. Inside the station, somebody reads incoming grid interruption reports from a tablet drifting beside the communications panel. Transformer failure. Regional load balancing. Cascading shutdown precautions. The language remains procedural and calm even while entire sections of coastline stop emitting visible light into orbit. Nobody reacts dramatically. Power failures happen constantly somewhere on Earth. But from orbit, the effect changes scale. Cities normally define the shape of continents at night. Coastlines become recognizable through human illumination long before oceans or terrain appear clearly beneath darkness. Electrical infrastructure acts like visual tracing paper across the surface of the planet. When the lights disappear, geography weakens with them. The station crosses above eastern North America. Cloud cover hangs low over several inland regions, but major urban corridors still remain visible through the haze. Dense concentrations of orange and white light connect metropolitan areas into continuous structures large enough to recognize immediately from orbit. Then one section fails. A corridor near the coastline vanishes almost all at once. Road systems disappear first, then residential grids. A few isolated industrial sectors remain illuminated for another minute before those fade too. Afterward, the area no longer looks populated. It just looks dark. Inside the module, one crew member manually marks the outage boundary on a transparent overlay sheet clipped beside the observation monitor. Dry erase marker. Estimated grid edge. Approximate restoration uncertainty. The marks remain slightly crooked because the station keeps drifting microscopically during observation. Nothing aboard feels urgent. Ventilation systems hum steadily behind the walls. Cooling fans cycle through familiar vibration patterns. Somebody opens a food warmer near the galley and the smell of heated tortillas briefly moves through the recycled air system before fading again. Outside, another section of Earth disappears. The adjustment happens faster now because the eye has already learned what to look for. At first, orbital night feels naturally incomplete. Oceans vanish, mountain ranges disappear, weather systems absorb light unpredictably. Darkness seems environmental. Then power failures reveal another layer. Some regions are invisible because sunlight is absent. Others become invisible because infrastructure stops functioning. Those are not the same condition. An archived control room recording from years earlier plays softly through workstation speakers during a maintenance review somewhere in Germany. Operators monitor satellite imagery during a widespread winter grid collapse while backup generators click rhythmically beneath the recording. One technician pauses the playback frame repeatedly. With power active, the coastline appears continuous. Without it, entire population centers dissolve into surrounding terrain almost immediately. He says something quietly that barely registers over the generator noise. You can watch civilization stop outlining itself. Nobody answers him. The recording continues with fuel estimates and restoration schedules. Back in orbit, cloud systems drift across South America while sections of inland electrical infrastructure fade unevenly beneath them. Some cities recover partially. Others remain absent from the planetary image completely. Thin highway chains still connect a few visible regions, but large sections between them now resemble uninhabited terrain from orbital altitude. Recognition begins breaking apart in pieces. Not because the Earth changes physically, because emitted light was performing more visual work than expected. One observatory operator disables older reference overlays temporarily to compare the live image directly against raw darkness. The effect feels immediately wrong. Without the remembered map underneath, several coastlines become difficult to identify at all. Urban clusters that normally anchor orientation no longer exist in the expected places. The remaining illuminated regions feel isolated and strangely temporary, like disconnected signals rather than stable geography. The operator restores the overlays after less than a minute. Recognition returns almost instantly. Labels. Borders. Expected infrastructure. Reference restores confidence faster than visibility alone. Inside the station, a small indicator light near the workstation flickers once during a routine voltage transition before stabilizing again. Somebody notices it immediately, even though nothing else changes. Tiny interruptions become harder to ignore after spending hours watching entire regions disappear below. Outside, the Earth continues rotating normally. Storm systems still move. Cloud bands still drift over oceans. The atmosphere remains faintly visible along the horizon. But parts of civilization now appear and disappear according to whether electrical systems continue emitting enough light to announce human presence against the surface. The station crosses over the Atlantic. Most of the visible hemisphere becomes ocean again. Only scattered island chains remain illuminated beneath cloud gaps. One small coastal region flickers weakly near the edge of the atmosphere before fading completely into black water. Then nothing replaces it. Just darkness where recognition used to be. Cloud systems rotate across the Pacific in thick white bands large enough to erase entire coastlines underneath them. At first, Japan remains visible through gaps in the weather. Dense urban corridors shine along the eastern shoreline. Cargo routes flicker offshore as moving points of light against black water. Then the cloud layer thickens, and the islands disappear almost completely beneath reflected moonlight spreading unevenly across the storm tops. The planet remains visible. The surface does not. Inside the station, a meteorological imaging feed refreshes slowly across one of the side monitors near the observation workstation. Infrared overlays cycle on, off, on again. Different wavelengths reveal different fragments of the same hemisphere. Temperature gradients appear where geography no longer can. Storm rotation becomes easier to identify than the continents beneath it. One crew member watches the feed while absent-mindedly tightening a loose strap around a storage pouch drifting beside the console. Nobody comments on the weather directly. Cloud cover this large is normal. That becomes part of the strange adjustment, too. From orbit, enormous sections of Earth disappear routinely for reasons that barely register emotionally anymore. Weather systems absorb coastlines. Atmospheric haze removes mountain ranges. Storm fronts erase entire national borders beneath reflected sunlight and moving ice structures. The eye adapts faster than expected. At first, the brain keeps trying to recover the hidden surface underneath every cloud mass automatically. Later, the clouds themselves become the visible object instead. The station crosses farther east. Now, only parts of Southeast Asia remain intermittently readable through breaks in the atmosphere. River deltas appear briefly as faint branching shadows before another rotating cloud layer folds across them again. Then, nothing recognizable remains underneath. Just movement. White atmospheric structures drifting over darkness with no stable reference visible below them. One archived weather observation recording from decades earlier captures an astronaut describing typhoon systems from orbit during a long overnight transmission delay with mission control. His voice sounds distracted, not emotionally overwhelmed, just visually occupied by something difficult to stop observing. He says the storm becomes easier to follow than the Earth itself after a while. The clouds move continuously. The surface underneath keeps disappearing. The transmission cuts briefly through static before reconnecting several seconds later. By then, he is discussing camera settings instead. Back inside the station, the observation windows reflect more interior detail again as orbital lighting conditions shift. Thin scratches in the glass catch monitor light near the edges of the frame. A floating checklist rotates slowly beside the navigation console until someone catches it and presses it flat against a magnetic restraint strip. Outside, cloud systems continue swallowing geography in pieces. The strange part is how complete the removal can become. A continent does not fade gradually beneath heavy weather from orbital altitude. It fragments. One coastline survives. One inland region remains visible. Then, another rotating atmospheric layer slides over both and orientation disappears almost immediately afterward. Recognition starts depending on persistence instead of visibility. You know the surface continues underneath, but the planet stops proving it visually for long stretches at a time. The station drifts above the Indian Ocean. Moonlight spreads weakly across upper cloud decks while lower atmospheric layers remain almost completely black. No coastlines, no islands, no shipping routes visible anymore. Only massive rotating weather structures illuminated unevenly from above. Without prior context, the scene would not immediately resemble Earth at all. One meteorological operator on the ground notices this years earlier during overnight satellite review while drinking stale coffee inside a forecasting center near Melbourne. A sequence of storm composites cycles repeatedly across several wall displays while rain hits the building exterior hard enough to vibrate the window frame. At one point, the continental overlays fail to load properly. For several seconds, the weather appears without geographic labeling beneath it. The operator later admits the image became briefly difficult to orient despite staring at planetary weather maps professionally every night for years. Cloud systems remained recognizable. The planet underneath did not. The realization arrives quietly, then stays. Back in orbit, the station enters another region of dense atmospheric reflection. White cloud masses now dominate nearly the entire visible hemisphere beneath the window. Their edges remain sharply illuminated while everything below them dissolves into low-contrast darkness. The Earth survives mostly through motion again, through rotation, through atmospheric flow, through the slow, organized drift of systems large enough to imply curvature beneath them. Inside the module, ventilation air moves softly through mesh storage compartments suspended along the wall. Someone tears open a packet of dried fruit. The sound briefly cuts through the constant mechanical hum before fading again into routine station noise. Outside, the cloud systems continue moving across hidden terrain no one aboard can currently see. Then for a moment, the weather thins. A coastline appears unexpectedly beneath the storm structure near the lower edge of the atmosphere. Faint, fragmented, barely stable enough to identify. another cloud band rotates across it, and the surface disappears again before recognition fully finishes forming. The telescope frame refreshes without finding the target. Stars remain visible immediately. Sharp, stable, thousands of them. But the tracking square near the center of the monitor stays empty. Inside the observatory module, nobody reacts at first because temporary loss during orbital repositioning happens constantly. One operator reaches across the console and taps a sequence of orientation commands into the guidance panel, while another checks the last confirmed coordinates against the station clock drifting along the upper corner of the display. Expected reacquisition window: 34 seconds. The timer continues, counting upward past it. Outside the observation glass, the station rotates slowly through darkness, while cooling systems vibrate beneath the floor panels with the same steady mechanical rhythm they maintained before the target disappeared. Nothing aboard feels unstable physically. Only the image does. The telescope shifts 2 degrees starboard. Stops. Corrects half a degree back. The tracking square moves with it across dense star fields, still glowing perfectly in focus. No Earth. One operator zooms out briefly to widen the search area. The stars compress visually. Constellation density increases. Small atmospheric artifacts drift through the lower edge of the frame from scattered light contamination somewhere outside the optical path. Still nothing recognizable. The Earth should remain present. That becomes the operational assumption holding the room together during the first several minutes. Not emotionally. Procedurally. Orbital mechanics remain predictable. Station position remains confirmed. Telescope hardware reports nominal alignment stability. The expected planetary pass should still intersect the observation corridor within acceptable tolerance margins. The system keeps searching because the object is assumed recoverable. A recalibration checklist floats loose beside the secondary monitor until someone presses it beneath a retaining strap and starts reading through the sequence line by line. Gyroscopic drift confirmation. Thermal distortion compensation. Optical axis verification. Background reference stabilization. The steps sound ordinary, spoken aloud. The empty square on the screen does not. One archived observatory recording from years earlier captures a similar reacquisition attempt after a deep exposure sequence near Jupiter. The technicians in the recording never sound alarmed, mostly irritated. Someone complains quietly about alignment software. Another blames thermal expansion across the mount assembly after prolonged sunlight exposure. Then one voice interrupts. Maybe we already passed it. Silence follows for several seconds after that. Not fear, just recalculation. Back inside the present station module, somebody opens a sealed drink pouch with their teeth while continuing to monitor the starfield. Tiny air bubbles drift upward through the liquid in slow, uneven chains every time the station thrusters fire corrective bursts too weak to feel physically. The telescope slews again, this time faster. The stars smear briefly into lines before resolving back into stable points as the mount settles. Tracking confidence markers flicker along the edge of the screen. No planetary lock. The strange part arrives slowly. At first, the operators search for Earth directly. Coastlines. Atmosphere. Weather systems. Artificial illumination. Then the search changes shape without anyone announcing it. They begin searching for interruption instead. Something large enough to remove stars behind it. A missing section of background. A curve. A gradient. Any disturbance stable enough to separate foreground from distance. Recognition starts depending on subtraction. The observatory darkens further as unnecessary monitor brightness gets reduced to improve contrast sensitivity. Instrument lights dim automatically. One operator places a folded cloth over a reflection source near the workstation because even small interior glare now interferes with low visibility scanning. Outside the station, the starfield remains completely confident. That becomes increasingly difficult not to notice. The background never hesitates. The Earth does. One operator pauses the automated search entirely and switches to manual control. The tracking square disappears from the screen for the first time in several minutes. Now only raw optical feed remains. Stars. Noise. Faint sensor grain. Nothing else obvious. The absence feels cleaner without overlays. Less wrong. Almost honest. A technician on the ground reviews incoming telemetry inside a control room where fluorescent lights hum softly above rows of mostly empty monitoring stations. Rainwater slides slowly down the exterior windows behind the consoles while someone near the back of the room tears open instant coffee packets beside a sink full of unwashed mugs. The Earth remains exactly where prediction models place it. That sentence gets repeated twice during the transmission review. Nobody argues with it. The problem is visibility, not existence. Back aboard the station, the telescope begins another sweep pattern across the expected corridor. Slow this time, methodical. The mount pauses every few seconds to stabilize vibration before continuing farther across the starfield. The operator stops speaking almost completely. Not from tension. From concentration fatigue. Long searches compress conversation naturally after a while. The observatory air smells faintly metallic now from warm electronics and recycled cooling flow moving through equipment housings that have operated continuously for years without direct atmospheric exposure. One operator rubs a thumb slowly across the edge of a laminated calibration card while staring at the monitor without blinking much anymore. Then something almost appears. A faint reduction in star density near the lower edge of the frame. Not enough to confirm shape, not enough to establish edge separation. Just a region where the background looks slightly interrupted compared to surrounding space. The telescope holds position. Everyone watches the same section of screen. The disturbance fades after several seconds. False acquisition. The search resumes. That moment changes the room more than the original loss did. Because now uncertainty has shape. The Earth remains physically present somewhere beyond the glass, beyond the telescope corrections, beyond the repeated recalibration passes moving patiently through the starfield. But recoverability no longer feels automatic. The distinction settles quietly into procedure. One more sweep. One more correction cycle. One more empty tracking square drifting slowly across stable stars. The footage begins with a small, unresolved point moving slowly across the lower corner of the monitor. Nothing about it immediately suggests a planet. No visible atmosphere. No coastline. No cloud structure. Just a faint concentration of light drifting against dense background stars during a long exposure sequence recorded months earlier and mostly forgotten afterward inside an observatory archive. The analyst reviewing the footage almost skips past it. Inside the workstation room, the air conditioner rattles softly above a row of dim monitors while old processing fans hum beneath the desks. Somebody has left a half-empty paper cup beside the keyboard long enough for dust to settle along the rim. Rain moves intermittently across the windows outside, visible only when passing headlights reflect through the glass. The analyst rewinds the sequence again. The moving point crosses the frame slowly enough that the motion only becomes obvious after comparison against fixed stars nearby. One frame, then another, then another. The background remains perfectly stable. The object does not. At first, the footage looks damaged. Deep exposure recordings often produce sensor artifacts that drift unpredictably across the image. Thermal noise, radiation interference, reflection contamination from optical surfaces inside the telescope assembly. But the movement remains consistent. Slow, directional, stable across multiple frames. The analyst increases contrast slightly. The point brightens without resolving further. Still no visible edge. Still no obvious planetary shape. Just movement against stillness. The strange part arrives later. Not when the object first appears. When the analyst checks the timestamp, the coordinates align almost exactly with Earth observation corridors recorded during the failed reacquisition sequence from earlier that week. The room becomes quieter after that. Not emotionally tense, procedurally narrowed. One monitor switches to archived orbital prediction data. Another loads reference star positions. Someone farther down the room removes headphones and rolls slowly across the floor in a wheeled chair without speaking yet. The moving point continues, crossing the frame. A planet should dominate visually. That assumption remains present even after everything else begins weakening. The Earth should appear larger than surrounding objects. Brighter, clearer, foreground. Instead, the footage behaves differently. The stars feel stable first. The moving object feels uncertain. One technician overlays reference markers manually across the frame using old calibration software that still requires point-by-point alignment input. Tiny crosshairs appear beside several stable stars while the moving object continues drifting almost indifferently through the field. The stars define orientation. The Earth does not. Nobody says that aloud immediately. But the room begins behaving around the realization before anyone names it directly. Conversations shorten. Movements become slower. One analyst keeps replaying the same 14-second section repeatedly while resting 2 fingers against his forehead without blinking much anymore. The object never sharpens. It only moves. Outside the building, rainwater collects along the edge of a parking lot beneath orange security lights, reflecting weakly through puddles. A delivery truck reverses somewhere near the loading entrance. The sound reaches the room faintly through insulated walls before fading again. Inside, the footage continues. Frame after frame. The Earth remains visually unresolved. An archived training lecture from years earlier plays silently beside the analysis feed on another monitor, while someone searches procedural notes regarding optical ambiguity during deep field exposures. The instructor in the old recording gestures toward a projected image containing several barely distinguishable points of light. Distance removes hierarchy, he says. Everything starts behaving like background eventually. Nobody currently in the room seems to like the sentence very much. One technician pauses the moving object beside a dense stellar cluster near the edge of the frame. For several seconds, the Earth becomes almost impossible to relocate visually once motion stops. The analyst loses it twice while staring directly at the screen. Movement was carrying recognition more than shape. That realization lands awkwardly. Not dramatic enough to interrupt procedure. Too operationally important to ignore. The footage resumes. Now the eye follows the object more carefully, but something fundamental has already shifted. The Earth no longer feels visually privileged compared to surrounding stars. It behaves like another unresolved light source crossing a crowded field of older lights already occupying the image before it arrived. Foreground and background begin exchanging roles depending on attention. One moment, the stars feel distant. The next, they feel structurally dominant, while the Earth drifts uncertainly between them. Inside the room, somebody opens a drawer full of archived calibration transparencies and spreads several across the desk beneath the monitor glow. Thin scratches and fingerprints catch the light along the plastic sheets. Old handwritten notes remain visible in faded marker near alignment references from observation sessions decades earlier. People have been trying to stabilize orientation against star fields for a very long time. The footage loops again automatically. This time, nobody watches the Earth first. They watch the stars around it. The motion becomes easier to see that way. Not the object itself. The disturbance it creates against stable reference. The analyst eventually increases magnification until the moving point begins breaking apart into sensor grain. Tiny fluctuations shimmer unevenly around the object as compression artifacts and optical uncertainties start overtaking useful detail. The Earth almost disappears completely inside the enlargement. Then one nearby star remains perfectly sharp. The contrast feels wrong immediately. The background survives magnification better than the planet does. No one in the room fully explains why that detail lingers afterward. But the footage keeps replaying long after the analysis technically finishes. A moving, unresolved point crossing stable stars. Still physically present. Still identifiable, eventually. But no longer behaving like the obvious center of its own surroundings. The indicator activates 12 seconds before anyone says the word Earth. A small green marker appears beside the lower edge of the monitor while the telescope feed still shows nothing visually convincing to the operators watching it. The stars remain stable. Sensor grain drifts faintly through darker sections of the frame. One unresolved point moves almost imperceptibly against the background. No verbal confirmation yet. Inside the control room, someone checks the identification sequence timestamp against the incoming optical telemetry, while another technician scrolls through recognition thresholds on a secondary display filled with columns of changing numbers. The system has already classified the object. The room has not. A soft notification tone sounds from beneath the monitor array. Nobody reacts immediately because the observatory produces hundreds of automated signals every hour. Alignment stability, exposure warnings, thermal fluctuations, archive synchronization. This one remains active longer than usual. Earth object confidence, 72%, then 76%, then 81%. One analyst leans closer toward the screen without touching the controls yet. The moving point still looks visually unresolved. No atmosphere, no edge separation, no recognizable planetary structure. Just motion. The machine recognizes pattern before appearance. That becomes difficult not to notice once it happens the first time. The identification checklist begins anyway. Orbital vector consistency. Background motion comparison. Reflective behavior alignment. Predicted transit confirmation. The steps move quickly because most of the verification already happened automatically before the room fully understood what it was watching. A technician reads the checklist aloud in short compressed phrases while someone else marks confirmation codes beside each category using an old mechanical keyboard with half the letters worn smooth from years of repeated use. Outside the building, rain has mostly stopped. Water continues dripping slowly from the edge of an exterior antenna housing near the parking lot, while distant traffic moves through wet intersections under sodium streetlights. Inside, the monitor updates again. Earth object confidence, 94%. Still, nobody says it immediately. The delay lingers. Not because the operators distrust the system, because visual recognition has not arrived yet. One archived observatory review from years earlier contains a similar delay during a near-field tracking exercise involving a dim asteroid crossing crowded star fields. The automated system identified the object 30 seconds before the operators agreed with it visually. At the time, nobody thought much about that difference. Now the timing feels heavier. The analyst finally enlarges the moving point slightly. The image degrades almost immediately. Compression noise spreads across the object. Pixel instability flickers near the edges. The stars nearby remain cleaner than the thing being identified as Earth. One operator exhales quietly through his nose and leans back from the monitor. "There it is," he says finally. But the sentence sounds less like discovery than synchronization. The room catches up to the machine. That becomes the operational sequence afterward. Detection first. Recognition later. Sometimes much later. The control systems continue processing continuously whether human certainty arrives or not. Background subtraction algorithms keep comparing motion vectors. Reflectivity databases continue matching optical behavior against archived planetary profiles recorded across thousands of earlier passes. The Earth remains mathematically recognizable before it becomes emotionally recognizable. Inside the room, somebody removes a printed checklist from the wall and replaces it with an updated revision containing additional verification steps for unresolved object confirmation. The older sheet folds slightly at the corners before being clipped beneath a stack of outdated calibration procedures nobody has thrown away yet. Tiny procedural changes begin accumulating around the delay, long after the original moment passes. One technician re-watches the sequence frame by frame later that night while eating microwaved noodles beside the console. The green confirmation marker appears again beside the unresolved moving point. 12 seconds. Then the verbal acknowledgement. The distance between those events remains strangely uncomfortable once noticed. Not dramatic. Not dangerous. Just difficult to stop thinking about afterward. Outside the observatory windows, clouds move slowly across a partially visible moon, while the parking lot below reflects weak silver light through shallow rainwater still gathered along the asphalt. Inside, the footage loops again. The machine identifies Earth immediately. The humans stare at it first, then compare it, then hesitate, then finally understand what they have already been looking at. The monitor no longer displays Earth directly, only coordinates. A thin grid overlays the star field while prediction markers update every few seconds across the center of the screen. Right ascension, declination, velocity adjustment, confidence interval drift. The object itself remains visually unresolved, but the tracking system keeps moving as if something solid is still there. Inside the observatory control room, someone adjusts the refresh timing on the ephemeris feed, while another technician compares live positional estimates against archived orbital models stored across a second monitor filled with pale green numerical columns. Nobody asks whether the Earth still exists inside the frame anymore. That question has already been replaced operationally. Now the concern is whether the coordinates remain internally consistent. The distinction settles quietly into procedure. One small white square drifts across the monitor following predicted motion paths generated hours earlier by systems that never required direct visual confirmation in the first place. The square pauses briefly during correction cycles, then continues moving again through empty sections of starfield where nothing immediately recognizable appears to human observers. Still, the software maintains lock. The Earth becomes present through agreement between calculations, not visibility. A technician drinks cold coffee without looking away from the screen while background processes continue updating automatically beneath the optical feed. Position prediction, relative motion compensation, reflective probability alignment. The monitor itself barely changes visually for several minutes at a time. Only the coordinates move. Outside the building, morning traffic begins forming slowly along wet streets beneath fading rain clouds. Headlights reflect weakly across puddles near the observatory entrance, while delivery workers wheel sealed equipment containers through side corridors lit by fluorescent ceiling panels that buzz faintly overhead. Inside, the room remains dim enough for the monitors to dominate the walls completely. One analyst disables the optical layer temporarily. The stars disappear. Now only the coordinate grid remains against blackness. Predicted object location. Predicted transit direction. Estimated visual reacquisition corridor. The Earth survives operationally even without the image. Nobody reacts strongly to this anymore because modern tracking systems function this way constantly. Deep space probes disappear behind planets. Satellites move through atmospheric interference. Telescopes maintain lock on objects hidden temporarily by solar contamination or signal distortion. The calculations continue regardless. But this feels slightly different now. Because the object being reconstructed procedurally is no longer distant or unfamiliar, it is Earth. One archived systems lecture from years earlier explains this casually during a software training session recorded inside a nearly empty university classroom. The instructor speaks while writing orbital prediction corrections across an old whiteboard stained faintly with erased equations from previous courses. Observation gaps are normal, he says. The object continues existing between measurements. At the time, the sentence sounds completely ordinary. Now it lingers differently. Back inside the observatory, the coordinate square shifts another fraction across the screen while the optical feed still shows only unresolved background stars drifting almost imperceptibly beneath sensor noise. The operators stop searching visually after a while. Not consciously. Procedurally. Their attention moves toward timing consistency instead. Update intervals. Motion prediction accuracy. Alignment stability. The Earth becomes easier to trust mathematically than optically. One technician prints a fresh tracking report from an aging machine near the back wall. The paper curls slightly as it emerges. Position updates, prediction tolerances, reference corrections. Tiny numerical adjustments describing the movement of a planet no one in the room can currently identify by sight alone. The report gets clipped beside several earlier printouts already stacked across the desk. Procedure accumulates around invisibility surprisingly fast. Outside, clouds drift apart briefly above the observatory parking lot. Pale morning sunlight reflects weakly across damp asphalt before disappearing again behind another passing weather band moving inland from the coast. Inside the room, the coordinate grid continues updating. Nobody watches continuously now. One analyst reviews archived footage from earlier passes, while another recalibrates exposure thresholds for future observation windows expected several hours later. Someone tears open a packet of crackers beside the console and brushes crumbs away from a keyboard already coated faintly with dust near the unused function keys. The Earth remains operationally present through all of it. Not visible. Tracked. The realization arrives late. Almost accidentally. Visual confirmation used to stabilize certainty. Now certainty stabilizes visibility instead. The coordinate system decides where observers should continue looking long before recognition arrives. Sometimes recognition never fully arrives at all. Yet the procedures continue functioning without interruption. One operator eventually restores the optical layer beside the tracking grid. The stars return immediately. Sharp again. Stable. The moving coordinate square drifts slowly between them, centered on empty space where the Earth is predicted to remain, whether anyone can currently see it or not. After several seconds, nobody in the room seems especially bothered by that anymore. A thin curve of light appears along the edge of the frame so gradually that nobody in the room notices it at first. The archived recording continues playing across the monitor wall while operators sort through older calibration logs and timestamp corrections from previous observation sessions. Most of the footage still looks unresolved. Dense stars, sensor grain, tracking overlays drifting slowly through blackness. Then the crescent brightens another fraction. One analyst pauses mid-sentence while reaching for a stack of printed alignment reports beside the keyboard. There. The word comes out quietly. Not surprised. Almost relieved. Inside the recording, the Earth finally develops an edge again. A narrow, illuminated crescent curves across the darkness with just enough reflected light to separate planetary shape from surrounding space. No visible continents yet, no weather systems, only a thin line of scattered brightness widening slowly frame by frame as orbital geometry shifts into a more favorable angle. The room changes immediately after that. People lean closer toward the screens again. Someone increases monitor brightness slightly. Another operator restores color correction settings that had been disabled during the earlier unresolved tracking phases. Recognition becomes visually easy for several minutes. The planet finally behaves like a planet again. Outside the observatory, morning clouds thin above the parking lot while weak sunlight spreads across wet pavement, still holding shallow rainwater between faded painted lines near the entrance gate. Inside, the crescent continues brightening. The strange part is how emotional the recovery feels despite how conditional it actually is. Nothing about the Earth itself has changed. Only lighting geometry. One archived imaging technician explains this years earlier during a recorded systems walkthrough while adjusting exposure controls beside an observation console lined with old adhesive labels peeling slightly at the corners.
The object was always there, he says.
You just need the right angle to separate it from everything else. Then he goes back to discussing phase correction settings and reflective thresholds without pausing long enough for the sentence to sound important. But the footage makes the implication difficult to avoid afterward. The Earth becomes obvious again only during certain windows. The crescent widens another degree. Now, faint atmospheric scattering appears along the illuminated edge. Thin blue contamination spreads softly into surrounding blackness, while the dark side of the planet remains almost completely unresolved, except for occasional sensor hints too unstable to trust visually. Still, the recovery feels convincing. More convincing than the coordinate grids. More convincing than the tracking squares drifting through empty star fields. Human recognition stabilizes quickly once visible edges return. Inside the room, somebody laughs softly after failing for hours to visually confirm the planet during earlier footage sequences that now seem strangely distant, despite occurring less than 1 hour earlier in the archive timeline. One operator rewinds the sequence several times just to watch the crescent emerge again from almost nothing. The motion feels reassuring. Predictable. Familiar. The Earth finally occupies foreground space again, instead of behaving like an unresolved object crossing stable stars. yet the stability already feels fragile underneath. Because everyone in the room now understands exactly why the recovery works. Timing. Angle. Reflection. Conditions. The visibility depends on geometry more than presence. Outside, wind pushes leftover rainwater slowly across the observatory roof drains, while passing cars move through fading puddles along the road leading uphill toward the main entrance. Inside, the archived recording continues. For several minutes, the planet remains visually undeniable. The crescent sharpens. Atmospheric glow thickens slightly. Small variations along the illuminated edge hint at cloud structure rotating just beyond the visible boundary line. One technician removes his glasses briefly and rubs his eyes before watching the sequence continue again without touching the controls anymore. The room stops behaving procedurally for a while. People simply watch. That absence of operational tension feels unfamiliar now after so many hours of coordinate overlays and unresolved tracking passes. No recalibration commands, no confidence intervals, no empty search corridors drifting across black screens. Just a visible planetary edge moving through darkness slowly enough for the eye to trust it again. Then the angle changes. Not dramatically, just enough. The crescent begins thinning almost immediately afterward. The atmospheric glow weakens first, then parts of the illuminated edge lose contrast against surrounding space. Background stars slowly regain visual strength near the dark side of the hemisphere. Nobody says anything during the transition because everyone can already see where it is going. The visibility was never stable, only temporarily favorable. One analyst lets the recording continue several minutes beyond the useful imaging window, even after the crescent has already narrowed back toward uncertainty again. The Earth remains identifiable, but less confidently now. The recovery begins dissolving almost as soon as it fully arrives. Outside the observatory windows, clouds move back across the morning sky, and the wet pavement below loses most of its reflected light once the sun disappears behind weather again. Inside, the crescent continues thinning frame by frame until the planet starts behaving more like a moving condition than a visible object. Still present. Still tracked. But only briefly obvious during rare alignments between light, timing, and where someone happens to be looking from. The ocean appears first as absence. The archived imaging pass opens on a section of the Pacific with almost no visible structure at all. The monitor refreshes slowly through low-light enhancement cycles, while stars remain sharp above a surface that barely reflects enough light to hold shape consistently from one frame to the next. No coastlines. No weather systems yet. Just a dark region where the Earth should continue. Inside the observatory, someone increases gain carefully across the lower half of the image, while another analyst watches for edge distortion near the horizon line. The enhancement software introduces faint grain almost immediately. Small fluctuations spread across the water surface like moving dust trapped inside the screen itself. The ocean does not become clearer, only brighter. That difference takes several seconds to fully register. One technician removes a pair of headphones and listens to the room again. Cooling fans, keyboard taps, a coffee machine clicking softly near the back counter where somebody forgot to empty the glass pot after the overnight shift ended. Outside the building, wind pushes damp leaves slowly across the observatory walkway, while weak morning light reflects off metal railings still wet from rain earlier in the night. Inside, the Pacific continues absorbing most of the image. The strange part is how incomplete the planet suddenly feels once land disappears. The Earth remains visible over continents almost automatically. Cities emit structure. Deserts hold reflected light longer than expected. Cloud systems reveal atmospheric depth through contrast and motion. Open water behaves differently. The ocean reflects only under certain angles. Outside those windows, the surface stops behaving like visible terrain and starts acting more like empty space, with occasional interference moving across it. One archived operator describes this quietly during a playback review recorded years earlier beside a workstation covered with old handwritten calibration notes taped near the monitor edges. "Land returns light," he says. Water mostly removes it. Then he keeps adjusting brightness settings without elaborating further. The footage continues. A thin atmospheric edge survives near the upper curve of the planet, while the ocean below dissolves almost completely into surrounding blackness. For several moments, the visible Earth consists mostly of atmosphere suspended above absence. The geometry feels wrong, even before the mind fully understands why. Oceans are supposed to connect the planet visually. From orbit, they sometimes erase it instead. One analyst zooms slightly toward a section of water where moonlight should be scattering across the surface according to the observation timing report clipped beside the monitor. Nothing appears at first. Then a weak reflection forms briefly near the center of the frame before fading again as the station angle changes by less than a degree. The reflection survives for maybe 4 seconds. Afterward, the ocean disappears back into blackness immediately. Inside the room, someone tears open a packet of powdered creamer beside the coffee machine while another operator rewinds the sequence twice, trying to relocate the reflected patch of water after it vanishes. The replay feels strangely unreliable. The planet keeps changing visibility depending on angle faster than memory expects. Outside, clouds drift slowly over the parking lot again, and the remaining sunlight across the pavement weakens beneath another layer of weather moving inland from the coast. Back on the monitor, the ocean now occupies nearly the entire visible hemisphere. The Earth stops looking spherical for a while. Without reflected structure, the curvature weakens. The horizon survives only through faint atmospheric haze, while the surface itself blends gradually into surrounding space so completely that the eye keeps trying to recover missing edges that are no longer visually present. One technician lowers enhancement intensity after noticing the software beginning to manufacture false texture across the water. Artificial wave patterns? Noise behaving like geography. The correction stabilizes the image immediately. Now the ocean becomes smoother again. Darker. More honest. The room grows quieter afterward. Not tense. Just visually occupied. A recording from an old maritime weather satellite review plays briefly on a side monitor while someone searches archived low-albedo reference passes from decades earlier. The footage shows large sections of nighttime Atlantic water almost completely invisible beneath cloud-free skies. One analyst in the old recording laughs softly after losing the planetary boundary during a frame transition. He says the ocean keeps eating the edge. Nobody answers him. The playback ends there. Back inside the present observatory, the Pacific continues rotating beneath weak atmospheric glow, while enhancement systems search continuously for contrast that never fully arrives. Occasionally, small disturbances appear, thin cloud bands, a faint shipping corridor reflecting scattered light, brief moonlit texture across rough water. Then the surface absorbs everything again. Recognition begins depending on interruption instead of visibility. The eye searches for anything the ocean fails to erase completely. A reflection. A cloud edge. A moving weather boundary. Without them, the Earth starts dissolving unevenly into its own water. One analyst finally steps away from the monitor to refill cold coffee that has been sitting untouched beside the keyboard for almost an hour. Behind him, the imaging sequence continues silently across the wall display.
Black water beneath faint atmosphere.
Stars remaining sharper than the planet below them. And a horizon that only survives where light manages to touch the ocean at exactly the correct angle before disappearing again. The playback freezes for a moment between frames and the Earth disappears completely. Not hidden. Not eclipsed. Just gone during the transition interval while the recording software loads the next exposure from archive storage. Then the next frame arrives, and the planet returns again almost exactly where it was before. Inside the observatory, nobody reacts because everyone in the room has already watched enough degraded footage to recognize buffering delays immediately. One analyst taps the side of the monitor lightly while another checks the playback cache indicator drifting near the lower corner of the screen beside the timestamp display. The recording resumes. Slow movement returns. A barely visible dark shape crossing unresolved blackness. At first, the eye still understands what it is seeing because memory continues carrying the object forward between frames. The Earth was visible 1 second earlier. The tracking markers remain aligned. Motion vectors still update correctly beside the image. Continuity survives the interruption. For a while. The footage advances frame by frame now instead of real time. Someone has slowed the playback manually using the control wheel near the workstation keyboard. Each movement of the dial produces another faint shift across the monitor. 1 frame. Pause. Another frame. The planet moves slightly against the background stars. Not enough to appear dramatic. Just enough to remain physically continuous. The room stays quiet except for cooling fans and the soft mechanical clicks from the playback wheel turning beneath someone's fingertips. A paper cup rests beside the console with cold coffee reflecting monitor light weakly across the surface whenever the screen brightness changes. Outside the observatory windows, low clouds drift across the remaining morning light until even the parking lot below begins losing definition beneath weather and shadow. Inside, the Earth keeps weakening. Not physically. Visually. The oceanic regions absorb almost all remaining luminance now. The atmosphere barely survives as uneven haze near one edge of the frame. Stars remain cleaner than the planet itself. One analyst pauses the playback completely. The Earth becomes difficult to relocate immediately afterward. Motion was carrying more recognition than shape. That realization settles slowly into the room without anyone fully saying it aloud. The technician resumes playback. Again, the object reappears through movement. Not through visibility. A dark, shifting interruption against stable background points. One archived imaging review from years earlier captures a similar sequence during low luminance tracking tests above the South Pacific. The recording quality is poor. Audio hiss drifts underneath the voices while someone adjusts brightness controls too quickly and washes the image nearly flat for several seconds. During the review, one operator stops the footage repeatedly trying to isolate the planetary boundary. Every pause makes the Earth harder to find. Eventually, someone else in the room says, "Keep it moving." The sentence sounds procedural at first. Later, it feels heavier. Back inside the present observatory, the playback continues advancing slowly through unresolved frames where the distinction between object and environment no longer behaves reliably. The stars do not end where the Earth begins anymore. The separation weakens across large sections of the image until the eye starts depending on expectation instead of direct observation. One technician increases contrast slightly. The result helps briefly. Then the enhancement begins sharpening sensor grain into false structure again. Tiny fluctuations gather near the horizon line, pretending to be edges that are not actually present in the original data. The adjustment gets reversed immediately. The image softens again. More uncertain, but less dishonest. Outside, rain begins lightly against the observatory roof. Small impacts tick across metal ventilation housings above the building, while runoff gathers slowly along the concrete edges of the walkway leading toward the entrance gate. Inside, frame-by-frame playback continues. The Earth drifts. The stars remain. Sometimes the planet survives only because the background changes around it differently than expected. One frame contains slightly fewer stars near the lower edge. The next contains a faint gradient too smooth to classify as atmosphere confidently. The next almost loses the object completely before motion restores continuity again. Recognition starts arriving late now. Several frames late sometimes. The mind keeps catching up to images it already saw seconds earlier. One analyst notices this accidentally after rewinding the footage multiple times through the same 10-second interval. During the first viewing, he identifies the Earth immediately. During the second, recognition takes longer. During the third, he loses the object twice despite already knowing exactly where it should appear. Expectation weakens once visual separation collapses too far. The room grows quieter after that. Nobody leaves. Nobody speaks much either. One technician rests both hands against the edge of the console while staring at the monitor without touching the playback controls anymore. The footage keeps advancing automatically now through barely shifting darkness, where the Earth survives mostly as delayed cognition attached to motion. Outside the observatory, the rain thickens enough to erase the distant hills completely beyond the parking lot. Inside the monitor, the same thing begins happening to the planet. Background and object continue merging slowly together. Not all at once. Frame by frame. Until the Earth starts behaving less like a visible world and more like a region where the sky moves differently for a little while, before becoming difficult to separate again. The indicator light turns green before anyone in the room speaks. A small confirmation marker appears beside the tracking feed while the monitor still shows almost nothing recognizable to the human eye. The Earth remains buried inside low-contrast motion and weak gradients drifting across unresolved blackness. But the system has already identified it. Inside the control room, someone reaches automatically for the printed verification sheet clipped beside the keyboard. Another operator checks timestamp alignment against the tracking archive without looking directly at the image anymore. The sequence has become routine. Signal confirmation. Motion comparison. Reference stability. Object continuity. The checklist pages curl slightly near the corners from repeated handling during overnight reviews. Nobody rushes. Outside the observatory, rainwater slides slowly down the edge of the windows facing the parking lot. A maintenance truck passes once through the wet entrance road, headlights briefly reflecting across the glass before disappearing behind the low hill beyond the building. Inside, the monitor updates again. Object confidence increased. The machine responds immediately. The room does not. One analyst leans closer toward the display, staring at the same section of screen for several seconds before finally nodding once toward nobody in particular. There it is. The sentence arrives late enough that the software has already moved several steps ahead procedurally. The tracking grid stabilizes. Background subtraction completes. Motion prediction updates automatically. Human recognition follows afterward like delayed echo. The Earth remains detectable the entire time. That is not the problem anymore. The problem is timing. One operator rewinds the sequence frame by frame, trying to locate the exact moment conscious recognition occurred. The process becomes strangely difficult almost immediately. The system identified the object first. The monitor indicators reacted second. The verbal confirmation arrived several seconds later. No single moment feels fully accurate afterward. Awareness spreads unevenly through the room instead of appearing all at once. A cooling fan changes speed somewhere beneath the workstation consoles. One technician removes reading glasses and wipes them slowly against a shirt sleeve while staring at the paused frame still showing almost no obvious planetary structure. Outside, the rain weakens again. Water continues dripping from the roof gutters beside the observatory entrance in soft, irregular intervals that barely reach the room through the insulated walls. Inside, another playback begins. The machine identifies Earth before anyone verbally confirms it. This time, the delay feels shorter. Not because the image improves, because the operators have started trusting the system faster than their own visual certainty. That adjustment happens quietly. Nobody announces it. One archived training review from years earlier plays briefly on a side monitor while someone searches historical recognition lag reports from older orbital tracking systems. The instructor in the recording speaks calmly while standing beside faded projection screens inside a nearly empty classroom. Automated detection exceeds conscious interpretation speed under low visibility conditions, he says. Then he continues discussing processing thresholds and optical latency measurements while students copy notes into paper workbooks beneath fluorescent lights that hum softly overhead. At the time, the statement sounds technical. Now it feels physical. Back inside the present control room, the Earth crosses the monitor again as little more than interrupted background motion. The operators recognize it eventually. The systems recognize it immediately. One technician notices something else several hours later during repeated playback analysis. The delayed recognition persists even after the operators already know exactly where the Earth should appear. Expectation no longer guarantees awareness. The mind still arrives late. That realization changes the room more than the original tracking problem did. Conversations shorten after that. Nobody sounds alarmed, just slightly cognitively tired. The monitors continue refreshing through low-contrast frames while the verification markers activate with mechanical consistency beside images that still look visually incomplete to everyone watching them. A paper cup tips sideways near one keyboard and spills cold coffee slowly across a stack of unused calibration printouts before someone notices and lifts it upright again without looking away from the screen. The Earth passes through another frame. The system confirms it instantly. 3 seconds later, someone quietly says yes. Then the playback continues, moving forward before the sentence fully settles into the room. The older recording looks better immediately. Not sharper. Not technically cleaner. Just easier to recognize. The archive monitor flickers softly as grainy footage from 12 years earlier rolls across the screen. The Earth rotates slowly beneath scattered cloud systems, while coastlines remain visible almost continuously through the entire sequence. City lights survive near the night boundary. Storm fronts separate cleanly from the oceans underneath them. Nobody in the room comments on it at first. One operator simply stops adjusting the playback controls. The image no longer requires constant correction. Inside the observatory, an older storage unit hums unevenly beneath the archive console while magnetic drives click softly somewhere behind the wall panels. Someone opens a metal drawer filled with labeled backup cartridges and faded handwritten timestamps stretching back across multiple observation programs that no longer exist anymore. Outside the building, rain has mostly ended. Wet pavement remains reflective beneath pale afternoon cloud cover drifting slowly over the hills beyond the parking area. Inside, the archived Earth continues turning. The footage contains imperfections everywhere. Compression noise, signal interference, occasional horizontal tearing near the frame edges. But the planet itself remains visually stable in ways the live recordings no longer do. One analyst leans back slightly while watching an older orbital sunrise pass recorded through outdated camera systems with lower resolution than the equipment currently installed upstairs. The atmosphere appears thicker in the archive footage. Not physically thicker, just easier to separate from space. The oceans reflect more light. Cloud structures hold edges longer. The Earth behaves more like an object. That difference settles quietly into the room over time. Nobody says the present recordings look worse. Nobody needs to. The technician inserts another archive cartridge into the playback system. The machine pauses for several seconds before the next recording loads. During the delay, the live monitor beside it continues showing current observation feeds where the Earth still drifts through low-contrast instability, almost impossible to visually anchor for more than a few moments at a time. Past and present remain visible beside each other now. One monitor shows recognizable planetary weather rotating above bright coastlines. The other shows tracking markers confirming objects that human eyes still struggle to locate consistently. A cooling system activates somewhere overhead with a soft mechanical thump that briefly vibrates through the ceiling panels. Someone tears a strip from a roll of aging masking tape and labels another storage case without looking away from the screens. The archive playback continues. A recorded thunderstorm system moves across the Atlantic from years earlier. Lightning pulses illuminate cloud interiors while moonlight reflects visibly across open water beneath the storm edges. The Earth remains unmistakable through the entire sequence. One analyst watches silently for several minutes before eventually asking what year the recording was captured. Nobody answers immediately. Someone checks the label twice first. The footage already feels older than the timestamp suggests. Not historically old. Visually old. The difference matters now. One archived training session from decades earlier plays briefly through a side monitor while someone searches comparison logs between historical observation clarity and present low luminance tracking conditions. The instructor speaks casually while rewinding weather footage through an old control interface covered in worn buttons, polished smooth from repeated use. Older recordings sometimes appear emotionally clearer than modern ones, he says. At the time, the sentence probably referred to nostalgia. Now it sounds operational. Back inside the observatory, the live feed loses planetary separation again for several seconds, while the archive footage beside it continues showing a fully recognizable Earth crossing stable cloud bands above visible ocean reflection. The room stops treating the archive like stored material after a while. It starts behaving more like recovered visibility. One technician begins using the older footage as reference during present observation analysis. Horizon comparison, ocean reflectivity checks, atmospheric edge behavior. The process feels reasonable procedurally. Still slightly wrong emotionally. The present increasingly requires the past to explain what the planet is supposed to look like. Outside the observatory windows, weak sunlight briefly reaches the wet parking lot before disappearing behind another layer of cloud cover moving inland from the coast. Reflections fade almost immediately from the pavement once the angle changes. Inside, the archived Earth keeps rotating slowly across the monitor. The playback speed remains slightly uneven because the old storage system occasionally struggles to maintain stable frame timing. Small jumps interrupt the motion every few seconds. Even so, the image feels calmer than the live feed. One operator notices something late in the shift while comparing synchronized orbital passes between present and historical recordings. The archive footage no longer feels like stored memory. It feels current. And the live observation beside it feels delayed somehow. Not delayed in transmission. Delayed in recognizability. The room grows quieter after that. Someone stacks unused verification sheets into a neat pile beside the keyboard. Another technician powers down one of the live enhancement windows because the processing artifacts have started introducing false atmospheric gradients again near the planetary edge. The archive monitor remains active. Old Earth footage continues looping softly across the screen while the live feed beside it keeps searching for stable separation between object and background. One image behaves like memory. The other behaves like uncertain evidence still waiting to become recognizable later. The live monitor almost looks empty now. Only a faint curved line remains near the lower edge of the screen. Thin, atmospheric scattering. Pale blue fading gradually into blackness without any clear boundary separating one from the other. No continents. No visible oceans. The Earth survives mostly as edge light. Inside the observatory, nobody adjusts the image anymore. The enhancement controls remain untouched beside the keyboard, while the final low-light pass moves slowly across the monitor wall. Someone writes the current timestamp onto a paper log sheet using a pen that skips slightly against the page before the ink starts flowing again. The room stays nearly silent. Cooling systems hum behind the walls. A small desk fan turns slowly near the archive console even though nobody remembers who brought it into the room originally. One empty coffee cup remains beside the playback controls from earlier in the shift. Outside the building, the parking lot has dried unevenly after the rain. Small sections still reflect the security lights near the entrance gate, while the rest has already turned flat and dark again beneath the night sky. Inside, the crescent continues drifting. Not bright enough to feel dramatic. Barely bright enough to remain recoverable at all. One operator leans forward slightly toward the monitor as if proximity might help stabilize recognition. The atmospheric edge sharpens for several seconds when the orbital angle changes, then softens again almost immediately afterward. The Earth appears strongest during transition. Not full visibility. Not total disappearance. Just the narrow interval where atmosphere still catches enough light to separate itself from surrounding space. The old archive footage remains paused on another monitor nearby. A fully recognizable Earth from years earlier hangs frozen above visible cloud systems and reflected ocean light, while the live feed beside it struggles to maintain even the outer boundary of the atmosphere consistently from frame to frame. Nobody compares them anymore. The difference has become familiar. One archived systems recording plays quietly through a side speaker while someone sorts old observation reports into storage containers beneath the workstation. The voice in the recording sounds detached and tired, mostly procedural. Edge visibility remains stable longer than surface visibility, he says. Then several pages turn. Nothing else follows the sentence. Back inside the observatory, the live crescent narrows another fraction. Now the atmosphere looks less like a planet and more like residue left behind by one. A trace. A curved indication that something larger continues beyond visibility, even though almost none of it can currently be seen. One technician reaches toward the brightness controls. Stops. Then leaves them alone. The room has already learned what overcorrection does. False gradients. Artificial edges. Noise pretending to be structure. The untouched image remains weaker but more trustworthy. Outside the observatory windows, thin clouds move across the stars, slowly enough that the motion only becomes obvious after several minutes. One aircraft passes far above the hills beyond the parking area. Its navigation lights blink through the cloud layer briefly, before disappearing behind thicker weather farther east. Inside, the atmospheric edge continues holden. Barely. The Earth no longer behaves like a visible world inside the live feed. It behaves like a condition that still affects surrounding light. The realization arrives quietly enough that nobody reacts to it directly. One operator removes a stack of unused verification sheets from the desk and places them back inside a cabinet without speaking. Another powers down one archive monitor completely. The older Earth disappears from the room immediately once the screen goes black. Now only the live edge remains. A thin curve crossing unresolved darkness. The observatory lighting dims automatically at the top of the hour. Ceiling reflections fade from the monitors. The room becomes softer, less separated. One technician sits motionless beside the console for long enough that the glow from the atmospheric edge begins reflecting faintly across the lenses of his glasses each time the frame refreshes. The image still updates continuously, but very little changes. The crescent drifts. The edge weakens slightly, then returns. Most of the Earth never reappears. Several minutes pass without anyone touching the controls. The final low light sequence keeps moving through the system automatically while the observatory settles deeper into overnight stillness. Somewhere behind the walls, an aging storage drive clicks softly at uneven intervals while archived recordings continue copying themselves onto backup systems nobody is currently watching. The atmosphere survives longer than expected. Not clearly, just enough. A boundary glow suspended against blackness where the rest of the planet used to be easier to recognize. One operator eventually glances away from the monitor toward the dark observatory windows beside the console. For several seconds, the reflection in the glass looks brighter than the Earth itself. Then the monitor refreshes again. The edge returns. Thin. Unstable. Still barely visible. The monitor refreshes again without improving. A dark region moves slowly across the center of the screen while surrounding stars remain stable enough to track individually. No visible atmosphere survives now. No crescent. No reflected ocean light. Only motion against fixed background points. Inside the observatory, the electrical hum from the equipment racks continues at the same low frequency it has maintained all night. One cooling fan produces a faint intermittent vibration every few seconds that nobody has repaired because the sound never changes enough to become urgent. The room stays dim. Most of the monitors have already been powered down. Archive systems continue running quietly near the back wall, while the live observation feed occupies one remaining screen above the central console. Someone writes another timestamp onto the log sheet. The pen skips again, then continues. Outside the observatory windows, the hills beyond the parking area are no longer visible. Cloud cover has thickened back across the valley. Only the security lights near the entrance gate remain visible through the glass. Inside, the dark region drifts another fraction across the monitor. The Earth is still there. Orbital calculations remain stable. Tracking systems maintain lock. The object continues moving exactly where prediction models place it. Nothing visually confirms this with certainty anymore. One operator zooms in slightly. The image softens immediately. Sensor grain spreads across the frame. Tiny fluctuations move through the blackness where the planetary boundary should still exist beneath the noise. The operator restores the original magnification without saying anything. Nobody tries enhancement anymore. The room learned that lesson hours earlier. False structure survives processing more easily than real structure does. Outside, light rain begins again against the observatory roof. Soft impacts spread unevenly across the metal panels overhead, while runoff starts gathering along the edge of the parking lot below. Inside, the monitor keeps updating, frame after frame. The Earth continues crossing the starfield mostly as missing contrast. One archived recording remains active through a side speaker from somewhere deeper inside the storage system. Old observational chatter, low voices discussing calibration intervals and orbital timing corrections from years earlier. The recording quality is poor enough that parts of the conversation dissolve into static before becoming understandable again. One voice says, "Hold the edge there." Several seconds pass. Then another voice says, "We lost it again." The recording loops accidentally after that because nobody notices the playback system repeating itself. Back at the console, one technician rests both hands flat against the desk without touching the controls. The reflection from the live monitor flickers faintly across the surface of the unused verification sheets stacked beside the keyboard. No one speaks much anymore. Not because the room feels tense, because very little changes now. The object moves. The systems track it. Recognition never fully stabilizes. A maintenance light activates briefly down the hallway outside the control room before shutting off again automatically. For several seconds, the doorway brightens enough to reflect across the observatory windows. The reflection appears clearer than the monitor image. Then the hallway darkens again. Inside the live feed, the Earth keeps moving through unresolved blackness while surrounding stars remain sharp enough to identify individually. One operator notices something late. The tracking systems no longer require visual confirmation from the room at all. The procedures continue successfully whether anyone recognizes the image or not. Position updates arrive. Motion vectors remain consistent. The object persists operationally. Human certainty stopped being necessary somewhere earlier in the night. The realization settles quietly into the room and stays there without expanding further. Outside the observatory, rainwater drips steadily from the roof gutters now. A single vehicle passes along the road below the hill, headlights briefly visible through the weather before disappearing behind the clouded ridge farther east. Inside, the monitor refreshes again. The dark region shifts slightly against the surrounding stars. Nothing resolves. The Earth survives mostly through continuity now. Not visibility. Not edge separation. Not reflected light. Just ongoing movement through stable background structure. One technician eventually folds the unused verification sheets in half and places them inside a drawer beneath the console. Another powers down the archive speaker after the old recording loops for the third time. Now only the electrical hum remains. Low. Continuous. Almost level with the rain outside. The monitor keeps running. Frame after frame. A moving darkness crossing space slowly enough that the motion only becomes obvious after waiting beside it for several minutes at a time. Near the end of the shift, one operator glances toward the observatory windows again. For a moment, the glass reflects the control room more clearly than the sky beyond it. Then the monitor refreshes once more. The dark region has moved slightly farther across the stars. Still physically present. Still unresolved.